Our next speaker is Ryan. He came to us from England, and as you know, it's a little bit harder than it used to be. So please show some appreciation.
Thank you.
Sorry, that was a bad joke. But Ryan is is working in Cloudflare now, and he's going to tell us about the no-build Utopia.
Thank you. Hey everyone. I'm going to speak about the front end today, and I'm going to hopefully make you all believe that Rails was right all along, and I'll show you how it's well positioned to kind of capitalize on the changes that are happening in the web platform. As just mentioned, I'm currently working at Cloudflare. I literally just joined. I'm a principal product manager, so I don't even really get to write code anymore. And I'm responsible for our real user monitoring web analytics product. So if any of you are interested in making sure that you have really great web performance, please check it out. You can use it completely for free. You don't even have to be using Cloudflare. You can use it as a standalone product. And the great thing about that product is that it gives me the insight across so much of the web because we power, I think it's over 20% of the entire web. I get insight into all of that data and I can see how things are performing in the real world. But yeah, you might be thinking, I don't recall Cloudflare ever using Rails. And it's a fair concern because we don't. But I did only just join in March. This is a new thing for me. We organized this conference before that happened. And I actually built on top of Rails for 2 decades. And the reason I joined Cloudflare is the same reason I was building on Rails. And that's because I love the web. I think it's a really precious and amazing thing. It's an incredible gift to the world. We can effortlessly reach global audiences. It's a single platform that kind of within reason, we can reach every device on the planet. Maybe not watches quite yet really, but we're getting there. And yeah, you can write once and deploy literally anywhere. There's no gatekeepers. There's no one stopping you roll out a release. So within seconds, you can put something in front of real people. One of my old software engineers at my previous company, he was prior to being a software engineer, he designed nuclear power stations. And he was like, yeah, some people go their entire career without even doing a release, getting one built. And once it's out there, you can't just easily refactor it. You can't be like, oh yeah, we realized there was a bug there, we'll just tweak it and it's all fine. So we're in this really special place, but the web's got a bit of a problem with JavaScript. We're now shipping, over the course of the past decade, we're now shipping 3 times the volume of JavaScript than a decade ago, right? And these figures just show the median. You can't really see, it's a bit high contrast here. Behind those 2 lines, there's kind of a range that show you that you can get the slides later. But across basically every different percentile, we are shipping them 3 times the volume now. So that's not ideal, obviously. And it's growing faster than any other resource. And that's a problem because JavaScript is heavier than any other thing. So like if you load an image, 100 kilobytes of image, it can be decoded by a GPU and whatnot, versus, parsing, compiling, executing JavaScript is a lot slower. It's a lot heavier. My colleague, Tim Kadlec, recently ran these stats and found that just year on year, kind of since the introduction of LLMs, he saw an increase of 15% on desktop and 10% on mobile. And yeah, his theory, if you look at when that started to happen, the better the LLMs got, generally, the faster the JavaScript started to grow. But you might be thinking, well, our devices are getting faster, right? Kind of is the answer. So if you look at an iPhone at the top there, if you're buying the latest one, or your users, your visitors are buying the latest one every single year, then you could say, yeah, as long as it's fully charged and it's not running on the efficiency cores, it's not in like low power mode or anything like that. As long as there aren't other apps doing all these other things and it's kind of in isolation, purely running a benchmark, yes, it's about keeping up with the volume of JavaScript we're adding. And again, the same thing on the Android side if you're buying those flagship devices every single year, which obviously most people don't do. But the interesting thing is these 2 lower lines represent 2/3 of new devices that get purchased. And if you draw a line over from the Galaxy A26, you'll find that it's about as fast as an iPhone 8 from 2017. So 2/3 of new devices that are purchased today are equivalent to a device that's, almost a decade old. And the trouble here is that, whilst we're all used to kind of tuning our back-end servers, we can, monitor the performance really closely. That's a lot harder to do on end-user devices, part of what my product does. And ultimately, we can't depend on those user environments for running our code. So kind of in summary, if your visitors are baller enough to be buying a flagship model every year, that's great. But software is just kind of expanding to fill this gap continually. It's Worth's law that goes all the way back to the 90s, and it's still happening today. But the bit that always perplexes me is really what's happening. Like, is the web getting substantially more interactive? I'm sure we're doing amazing things at the kind of 99 plus percentile. There's amazing odd applications, but that's not most of the web. And I tried to look at like what I kind of summarized to the LLM as like what are the web's kind of greatest hits. And I was trying to categorize this into kind of rough areas around kind of the capabilities that they depend on, kind of technologies they're using on the web, and how they push things forwards. And this isn't an exhaustive list by any measure. It was just kind of some highlights. But most of these things are over a decade old. So it's not like we're just magically coming up with these amazing new things. Like even with AI and everything, most of that's sitting on a server somewhere. It's not things we're really doing in the browser. If we go back even further than a decade, for any of you who've ever played RuneScape before, they actually made a web version of it. They did can it because it had performance issues. But at that point, they're trying to, they're rendering 3D in real time with dynamic shadows and all that kind of good stuff, trying to aim for over 60 frames a second. So, us trying to just arrange some rectangles on a page and process some form input seems kind of silly in comparison, really. We should be so fast at that. But our JavaScript isn't purely just a performance issue. If the JavaScript has kind of 3x'd on the client, then it's probably 3x'd kind of behind the scenes. We're doing more internally, and that means that we have to maintain all of that JavaScript. So until March, annoyingly, they literally changed this as I started to prep this talk. This was the kind of mantra on the Rails homepage. It's similar today, but they've tweaked it to be kind of more AI focused. And I really love this, like compressing the complexity of modern web apps. Like if only the JavaScript side could get on board with this. And I find it really disappointing because Rails comes with these really great tools, Hotwire, Turbo, Stimulus, etc. But so many people just kind of put them in the bin and go, you know what, we're just going to make it an API. And they onboard like a massive single page app framework. And when we do that, we have to maintain so much more. You've got the framework itself, you've got all the libraries you might be using, and like I can't. So my previous company, we had a big single page app, Next.js app, and we were. I can't tell you how many times we updated like routing libraries and client side state management. It was just kind of this endless churn for no real gain for the actual customer. You've also got things like bundlers. You've got to try and make sure that the stuff you are outputting is hopefully as performant as possible. Transpilers, you make sure you've got that kind of backwards compatibility. And then you've got your dev servers, and they're running side by side to Rails on your laptop and everything. And then hot reloading and all that kind of stuff as well. So to kind of summarize, like npm install, just like bundle install, isn't free. Like we are bringing those dependencies in. We are responsible for those. And we're kind of borrowing against our future productivity. And it kind of results in this kind of abstraction that sits between our input, our code, and the actual user experience that we give to our visitors and our users. And ideally, we do want to be spending time on those things, really kind of crafting that for our users. And anything kind of in this abstracted layer between is really just kind of time wasted. We don't want to have to fight against the abstractions that we bring in. And people are doing this all for, bringing this complexity in for, well, there's going to be lots of page views and, we want it to be as snippy as possible. But in reality, most single page apps on the web actually only see one soft navigation, i.e. the one after you've landed, one click. That's it on average. So we're loading all this extra JavaScript just for one click. It doesn't really add up. So you might be thinking, where does Rails fit into this? We're building really serious applications in this industry, which is great. It's a very mature framework. And actually, Rails is doing really, really well. If we compare it to the JavaScript frameworks on this chart, Rails is up here at the top. So these are the core web vitals. So for any of you who don't know, there's 3 metrics that the kind of web performance industry has standardized to a degree with the backing of Google for measuring perceived performance. So this is, what does the user feel, as close as possible. We've got one for kind of loading performance, there's one for visual stability, and there's one for interactivity responsiveness. And you can see that in terms of origins that pass all 3 of those kind of thresholds for those metrics, Rails is jumping ahead of everyone else. So if you stick with what Rails already has, you're onto a good thing. But of course, as I say, many people just see it as an API and then they front it with all these big JavaScript frameworks. So that kind of made me think, is Rails, was it right all along? Do we need this kind of return to our raw materials, our HTML, our CSS, and JavaScript? So if you'll forgive me a little bit, we need to obviously rewind and understand where Rails came from to understand, had it made some right decisions along the way. So I picked up Rails in 2005. Back then, we weren't even using Git. I had to check it out of SVN. I had to learn SVN to actually get access to the code, which was a whole new thing for me. I didn't even use version control before that, embarrassingly. But yeah, and then I remember printing the docs off in a ring binder to take on holiday with me, because back then, we did have dongles that you could plug in to get, well, it wasn't 3G yet, but internet of dial-up quality. But you had to pay like £10 a megabyte to get access to it. So I printed it all off. I was the cool kid on the airplane, reading these things on this holiday. And I checked out Rails, and I would just, I probably spent more time inside just in awe of the productivity than I did outside in the sunshine. So yeah, I was the cool kid. But back then, we just dump our JavaScript and our CSS and stuff into the public directory and be like, yeah, there we go. But at least we knew what we were putting in there to a degree. Fast forward to 2006, Rails 1.1 came out, and this introduced RJS, which allowed you to run some JavaScript from the server effectively in response to HTTP requests. So we had some nice APIs like inserting HTML, replacing HTML, etc. You could even do little visual effects using what was probably terribly performant JavaScript back then, but we didn't know any better. Fast forwarding again to 2009, sprockets as a gem came to be, and we started to adopt that. And then Rails made that official in 3.1. And what that gave us is the ability to concatenate files together so we could get improved compression. It gave us the ability to minify that so we could reduce that code down even before compressing it. And then fingerprint them. So that way, the little hashes that you see in the URLs, we could tell the browser when it needs to download the new version just by the URL changing for us. And we also saw CoffeeScript and Sass, which were a kind of response to the fact that the browsers move very, very slowly. We wanted a better syntax for JavaScript. We wanted a better syntax for CSS. It's not easy just to roll those things out. Those things are now deprecated. You can do most of the features that they had are now all baked into the browser. So there's no need to use them today. But we were kind of trying to push the envelope a little bit there. In the same year, Chris Wansroth of GitHub introduced a library called PJAX. This was a library where you click a link, it would intercept that, it would download the page, and it would just swap the HTML over. So that way you'd kind of get this single page app style thing. And then Rails made that official with turbo links in 3.2, and then that actually became a default in Rails 4. Then the dark years started. I have to say that I was kind of part of the problem here. In terms of resume-driven development came in. Everyone wanted to be like the Netflix's, Amazon's, Google's, Meta's. I don't think it was Meta back then. It was probably just Facebook. But yeah, we wanted to all act like these massive companies. We were like, yeah, we should be using microservices. We should be using NoSQL, GraphQL, single-page apps. And everyone, I think it was just a response to trying to make a lot of our jobs that were very technical and complex, visibly so. So people would value the work we're doing, and particularly on the front end, that was kind of always treated as this kind of like, oh well, kind of, it's not real programming, that stuff. So I can see why that all came to be. And Rails had to kind of respond to that. So it introduced Webpacker so that we could bring in Rails, Vue, Angular, etc., and make that kind of experience a little bit more native. So effectively, this was the point at which we traded this left side for replicating pretty much everything on the client. I say, dark times. And we put all of that burden not on just our visitors, our users, but on ourselves as well, because we had to maintain that. And that's why people have been continually pushing for let's write some JavaScript and have it run on the server and in the client. What could possibly go wrong with security there? So thankfully, Rails helped us move out of the dark times with Rails 7, where the import map integration was brought in. And that effectively, all that really means is that it was a response to HTTP2 becoming supported in browsers. And what this meant was that there was a much smaller overhead for downloading lots of small files versus one big one. So that way, if you roll out a release, you only have to download the files that have changed, and it doesn't break the cache of that one big file. So we were responding to what was happening on the web. Hotwire and Turbo replaced Turbo links, and PropShaft, because now we didn't need that concatenation and we didn't need the minification. That was a minimal replacement for sprockets, and it still stands today. So you can see we've kind of come full circle, where we've almost removed all of the bits that have been introduced along the way. I mean, you can still obviously use React and Vue and all that stuff through Webpacker, but there are options here to go back to this much more minimal, almost no-build world. And that's something that I think we really need to do. There was a post that came over last year by Lorenz Stewart, where he talked about how we've kind of been sold this binary view of you're either building server-side rendered HTML, and that's for not real businesses and not real websites. That's just toy stuff, your own personal blog and all that kind of stuff. Or you jump up to the world of single-page apps, and that's what real, software engineers are building. But really what he's saying is that it should be a gradient. Too many people are starting at the bottom of this complexity stack and say, yep, just jump into a full framework. Whereas reality, most people should start right at the top there in the first few categories, a bit of JavaScript here and there. And that's kind of where Hotwire and Turbo live. Level 4 in his, he's not a Rails developer, but it's awfully similar to Stimulus. So you can see how kind of Rails naturally fits into this space. Effectively, we should be growing our complexity kind of organically rather than just jumping into it from the get-go. And really, we should be resisting that complexity all the time, refactoring back to more simple approaches as much as possible. Absolutely. So I've messed up my animations now. I'm going to have to sit and watch these. I don't know why it's going at about 2 frames a second, but there we go. There we go. Right. So the web kind of responded to files not loading, the overhead of loading individual files, and created HTTP2. Import maps were created in the web platform. We replaced that need for sprockets. ES6 came along and replaced CoffeeScript. SAS has been eaten away at by native CSS alternatives. So continually the web platform's doing that. And for the second half of this, I just want to take you through 5 brand new. Some of them are not even out yet. Some of them have been in the browser for a couple of years. APIs that will hopefully convince you that you shouldn't just jump straight into single-page apps. So first one is view transitions. So view transitions, there's 2 levels to these. It's a declarative way to handle page transitions. Now, this might be within a page, kind of SPA style, like you're making a change to the DOM, or it might be between pages. So you are just doing server-side rendering, but you want to transition and give that really nice UI. So we can bring that kind of app-like fluid UI that single-page apps have promised without all the kind of baggage and the weight of doing that. And the way that we do it is literally with just a couple of lines of code. So for level 1, it's JavaScript because it's, you're having to mutate the DOM. And for level 2, between the pages, we do that with just CSS. It's literally one line each. So this is the API to perform transitions within a document. And this is the API in CSS for doing it across documents. You can obviously go a lot further. This will just create a kind of fade between the pages, depending on how they change. But you can completely customize those animations. And if you want to transition two elements, just say you've got a page that looks like YouTube, loads of videos, and you want to be able to click on one and have that kind of expand, you just need to give it a name so the browser knows kind of before and after, where has it moved from to. Simple as that. So I've got some visuals here to kind of demonstrate what this looks like. So the right-hand side, this is the kind of single-page app version, the level 1, where we're filtering on an e-commerce page. I'm not the best at doing the animations. I'm not a designer, but you can see the kind of process where, as we change some of the filters, the products change and you get a nice little animation. And as I say, you can customize that however you want. On the left, we've got a more traditional, server-side rendered, multi-page app. And this is animating between the two screens automatically. And literally all we've had to do here is add those view transition names to each of the products so the browser knows to kind of animate between them. Simple as that. So when can you use this? Level 1, the kind of single page app version, is in all of the browsers now. And the nice thing is that if they're not supported, if you're going way, way back, they just get an instant, there's no animation. So yeah, some people might not get the beautiful kind of fluid experience, but they'll still get something that's really fast because you've removed all of that burden. And with level 2, across pages, this isn't everything but Firefox now, but that's covering most of the web. And again, they will just get the regular page view rather than that kind of fluid approach. Now, if you want to make the kind of cross-document transitions as smooth as possible, you really want to minimize your time to first byte. Because this is just kind of the browser, you're going to click something, the browser's going to wait for the new document to arrive, and then it's going to do the animation. So obviously you might need to put some loading state in there for that, but we can hide that latency with the next API, which is speculation rules. So again, these are declarative API for either prefetching HTML documents or completely pre-rendering the whole page. So this is absolutely incredible for performance. So we can hide the latency and give truly instant page loads. Like React, etc., cannot be as fast as this. I'll explain why in a second. And the way that we do this is just via a little blob of JSON. So there's no JavaScript to write, no anything else. It literally looks like this. You tell the browser basically how to discover the links that you want to either prefetch or pre-render. The top level key is either prefetch or pre-render to tell the browser. You can use them in combination, so you can say prefetch these links, pre-render these ones, or do it in different behaviors, which I'll come on to in a second. But yeah, you can either use URL matching or match based on CSS selectors. If you update the page, the browser will automatically look for these things. So if you're doing something like type ahead search, and then you want someone to be able to click on a product, say, for example, or a search result, and you want that to be instant, you can hook that up here. So visually, it's really hard to show this because it just makes it instant. So this is a pre-rendered site. It's effectively on hover of a product, it would pre-render the next page. As you can see, it is just instant. I try to show the little flicker of the mouse there as it gets clicked. But Chrome does have a panel to kind of inspect this stuff. So you can see the kind of two success labels on the right-hand side there. That's showing that Chrome has used those pre-renders. So the way this works kind of behind the scenes is it effectively creates kind of two tabs, but the second one is hidden behind the first one. So as you click the link, it literally just goes, boop, there we go, swaps them over. So that's how instant it can be. Even with like React, if you've got a page that depends on, say, like a network request, it's still going to have to, even if that network request has already been cached, it's still going to have to like mutate the DOM, and that's going to take some time. So this is still faster. The only trouble with going this full pre-rendering approach is that it can be really wasteful on resources. You don't want to be downloading entire pages if someone doesn't actually go to them. It is kind of a speculative approach. And because JavaScript will execute, you have to be careful with your analytics libraries because it might think that people are browsing way more pages than they actually are. Most analytics platforms have updated now their APIs to deal with that. It's just something you've got to be careful with. So your first line of defense against kind of this overuse of resources is the eagerness level. So you've got a few different options here, and they behave differently. And this is the really nice thing about this API is that browsers can change this over time. You give it a key of like, this is the kind of level I want. Is it based on actually clicking something? That's the most conservative approach, literally called conservative at the top there. Is it based on hover? And you've got a couple of options kind of in between. Or are you just saying, please pre-render or prefetch this as soon as possible whenever the browser's idle. So if it's not busy downloading the page already, it will go away and it will immediately do this stuff in the background. So you can vary that. You might say, okay, my prefetches, I'm going to do those as immediate because it's just a bit of HTML. I can make those really small files and it'll download really quickly. But for my pre-renders, I'm going to keep that conservative. I'm going to wait for someone to actually click down and just capitalize on the 100 milliseconds before their mouse pops back up, or the same on mobile. And the second defense is the actual action. As I say, you've got pre-render and prefetch. These are two distinct options. Pre-render is the most resource heavy, but and that does give you the best experience because it is instant. With prefetch, all we can save is that kind of time to first byte. It's not going to discover any sub-resources, so your style sheets, any JavaScript, your images, etc. But Google are working on a middle ground, which is pre-render until script. So what this will do, it's still fairly heavy, so it's more towards pre-render, it's handy that they've named it that. But effectively, what this will do is, like it says on the tin, really, it will start downloading the page. As soon as it finds any script tag, it will just stop. So the pre-parser will still run, so it will discover all the resources that are in the HTML. But as soon as a script tag is discovered, it will just stop at that point. And then that way, you don't have to worry about your analytics or anything like that. You can pre-render safely. So they're working on that at the moment. Unfortunately, it's a Chrome-only API at the moment. Chrome implements both of these things. Safari are about to release. I think the work is done, but they haven't actually pushed it in a release yet. We're all kind of waiting for it. They're about to release prefetch. They have some concerns over pre-render. I don't know whether that's technologically or privacy. They do like to protect that side of things. So it is coming soon. Our third way to kind of mitigate that overhead is, of course, to make things as small as humanly possible. So this affects not only our JavaScript, it could affect our scripts, it could affect any kind of text resource can be improved with compression dictionaries. So this is a new RFC under the IETF. It got approved in, I think, September last year. So it's a brand new standard. And what it does is it lets you use a resource that you've already downloaded to compress a resource that you're downloading next. So this affects two different things. Firstly, if you're updating your app, say you've rolled out a new release, you've tweaked some JavaScript, you've fixed a bug, you might have only changed one line of code. Now, at the moment, you'll have to re-download that whole file. So if it's a 50 kilobyte file, one line of code changing, means 50 kilobytes more getting re-downloaded. With compression dictionaries, you can say, okay, well, we've got version 1 stored locally on the user's device. Their device will tell our server, hey, I've got version 1, give me version 2, but use version 1 to compress it. So you only have the little diff. So we can get down to bytes in terms of changes there. Effectively, by doing this, we can compress other types of files as well. We can download a dictionary that we've built based on other contents of other files. It doesn't have to be just one JavaScript file, for example. It can be a whole bunch of different things. We can use that as a dictionary to compress anything else that's text-based. So the way this works is just a couple of HTTP headers. That is kind of trivializing it somewhat because actually applying the compression is something that's a little more tricky. But there's libraries out there. If you use Brotli or ZStandard, you can integrate your dictionaries with them. So it's just a little bit of code. This is ideal to kind of just bang in your CDN of choice. use like a worker or something like that, and you can kind of deploy it more as like infrastructure rather than necessarily part of your code base. So yeah, it completely changes the level of compression we can achieve. So just say we've got a file that's uncompressed. Obviously, it's 100% of its own size. gzip and Brotli, we might half it, for example. Obviously, it all depends on how much repetition's in that file. But then with dictionary compression, we can get like 90% on top of that. So these files are getting to be like 5% of their original value. This is my personal site. Just opened, I opened the homepage and then navigated it to my events page. And because that, in the other browser, it will have the dictionary. In Firefox that doesn't support it yet, I get like a 20 kilobyte download for that page. So 85% compression ratio. It's a fairly large HTML file because I'm inlining loads of styles. With Chrome, I get 5 kilobytes. So I achieve 96%. And so it's a quarter of the size that the other one was. And this means that when it comes to things like prefetching, we could do 4 times as much, or we can be as 4 times as lax. Or, if we've got quite a heavy site, we can, dial that back a little bit and not be so heavy for our users. So I mentioned kind of standalone dictionaries. And the way that this works is, if we compare it to single page app, they were pushed as like you download your shell, and then that makes like a call for some JSON, and then that is rendered to produce our page, our content. We can now effectively achieve the same thing just with compression dictionaries. So we've got a shared header and footer that are across all of our pages. That's our shell. We download that, including probably our content for the first page. Then when we make the request for the second page, we just do a regular navigation. But because we've already stored the header and footer, we're just loading that kind of diff in between, and we get the same experience. So you basically look for commonalities across different pages on your site. These have all got the same header. It's got like a mega nav in there. That could be a massive amount of content. You might have your head tag. That's one of the most important things to get loaded as soon as possible in terms of performance, because it'll discover loads of things like your style sheets, get them downloading really quick. So we look at those and we go, yeah, all of this is duplicate. And basically, you could just copy and paste that into a text file. Like, make sure not to include anyone's personal information in there. But as a trial, you can literally just do that by hand to see the impact of this. Then you load that dictionary as a standalone dictionary. So you just tell the browser with a one link tag, hey, can you download this? Again, in idle time, after the page is downloaded, it will go away and download that dictionary. And then basically on that dictionary, you need a HTTP header to say, hey, browser, when you get this, just store it locally as a dictionary and use it for other documents. So you can match based on different things. You could say, use this for JavaScript, use this for CSS. You could say based on root, and I'll show that example in a second. But that's all you really need, other than actually applying that compression when it comes back in. So just to kind of visualize the kind of hops between the browser and the server, originally, your browser is going to make a request for a resource. So take the JavaScript example here, v1.js. Browser's going to be like, okay, I don't have a dictionary, so I'll just request it as normal. And the server will say, right, okay, I'm going to serve this as a dictionary for any future version of this JavaScript. So it will store it. You need somewhere to store this across releases. So we can't just, disappear our assets between releases. That's one little nuance of implementing this. But just say you put it in a cache somewhere. And then it returns it and says, hey, use this for future versions of this JavaScript file. And we're just going to encode that with Brotli. So we can't use a dictionary, nothing fancy. The browser stores that as a dictionary, as well as using it, of course. And then we do a release. Version 2 comes out. So the next page view, the browser goes, hey, I need v2 now. So it looks up, it's got the dictionary. So it will tell the server via just a hash of the file. It will say, hey, I've got this dictionary stored locally. And then your server just needs to go, okay, can I load that dictionary from the cache? So you just store them keyed by hash, basically. And if that exists, great. We compress the new response using that dictionary. So literally your one line of code will be the diff, and we send that back with a different encoding. So this is encoding it with Z standard, so DCZ for Z standard. There's also DCB for Brotli. So depending on what stack you're on, different libraries have different kind of ease of integration. When you use this, the kind of actual compression that you use, it becomes far less relevant because it's so good at compressing things that you're saving bytes here and there, when just implementing dictionaries can save you kilobytes. So yeah. When can you use this? It's in Chrome today. Again, like Firefox had an implementation. They rolled it out, I think, to their Canary builds, but they had some bugs with it, so they've rolled it back. So theirs is basically done. They're just refining the bugs. Safari, I saw yesterday, I think it was. They've started pulling in all the tests into WebKit for it. So it to me looks like they're starting to work on this as well. But the great thing is, because you have to still be able to respond with these old formats anyway, without the dictionaries, it's a progressive enhancement. So there's no reason to not implement this today. You can literally, Chrome's half the web or thereabouts. So you can improve things for 50% of your users, if not more, depending on your use cases. And then you get the extra benefits when the other browsers adopt it as well. So even with compression dictionaries, we're still shipping around JavaScript. We still have to pay penalties around latency and things like that. There's still runtime execution. We still have inaccuracies in our speculations and things like that. So this is where the kind of fourth API comes into play. So this is invoker commands and interest invokers. So these let us build interactivity without even having JavaScript at all. They're similar, a limited use case at the moment, but it is expanding. So there's this kind of uncanny valley between you download a page and then JavaScript kind of arrives in a little bit, and then you can actually interact with it. Great. So in that middle time, people have started rage clicking on stuff because they're just like, why is this not responding to me? So we have this kind of awful place in the middle here while we're waiting for our JavaScript. These APIs let us kind of remove that, and we get the interactivity kind of for free, which is great. And it's literally just HTML. So with the invoker commands API, these sit on buttons, so you can trigger any command. You can write your own commands. At the moment, the native ones are only for working with the dialogue element. So it sounds like a fairly minimal use case, like dialogues, but actually, you've got burger menus, or other types of menu. You've got things like cookie banners, any kind of slide-in drawers with forms in them and things like that. Can all use this. And literally, it's just a couple of HTML attributes. So you've got command for, which you give it the ID, and then tell the command, open this as a modal. And the idea is that the Open UI group who kind of pushed for this and standardized this are looking to expand this to loads of other commands. So playing and pausing videos, for example, or incrementing and decrementing number fields. So that's literally my kind of next example. At the moment, we don't have this. So you have to write your own command. So you can see here that my custom commands are prefixed with 2 dashes. That's required by the standard. So what this means is that you no longer have to attach click events to things. The browser will just trigger these command events, and it will trigger them on whatever ID you give in that command for field. So in this instance, all I've got to do is write the little bit of JavaScript, hook it up to the item quantity field, and say, when I get step up or step down, I want you to do X or Y. So it does, this, when you're implementing your own stuff, it doesn't completely remove the JavaScript, but it does remove all of that kind of boilerplate stuff of, I just want this to be, I want to link into this clicking, it does that for you. And then on the interest invoker side, this is a newer API. This allows you to do things like have little pop-ups when you hover things, and it caters for mobile. So on mobile, if you long press, it'll come up with a little extra context menu that lets you trigger this. So say, for example, you've built a social network or some site where you can kind of like things, and you want it so that when you hover that, you can see who else has liked it. Again, just a little tiny bit of HTML, and you can achieve that. And I've got a visual that kind of shows this off. So this is a little demo site. The code for this is on GitHub, and there's a QR code at the end. So you can see as we hover over, it's gone too far ahead, but I didn't want to do a live demo. As we hover the little pills, it gives us a little popover that tells us when those items were published. And that's great. That's the interest invoker API. And then this edit literally opens this drawer. Again, no JavaScript to open and close that. That's all just native of the page. There's no, you'll just have to believe me because I don't have the code on screen, but there is no JavaScript running on that page. And the great thing is that in terms of invoker commands, you can use them today. They're in all of the browsers, and there's a little tiny polyfill. So if you want it to go really far back, then you can. It's a few kilobytes, and obviously you won't need to load that on anything modern. Interest invokers, they're working out some of the kinks just in terms of Safari has different UI when you like long press and things for like opening tabs. So they need to come up with a solution of how to integrate it. But that is something that's going to come along. And to be fair, a lot of tooltips just don't work on mobile at all. So, Safari may not be your problem. There is a polyfill for this, but obviously it only works on desktop because that has hover events. And our final API. So this is something that's really exciting to me. Very simple, like the others, but it's an experimental API that kind of brings Hotwire to the native web. So we'll be able to effectively integrate kind of any front-end component with any kind of back-end using the kind of same process. So why might we want to do this? Well, again, we remove JavaScript. That's great. We don't have to care about isomorphic rendering because we've got the server side just powering those kind of partials, those HTML bits that we're rendering. And it takes, for slow pages, just say you've got something like a dashboard and you've got loads of charts that take loads of time to run some queries. You can just stream that HTML out of order. And this API lets you reorder your HTML as it streams down to the browser, which is really cool. So yeah, I'm really excited for where this goes. So how this works is literally like a template tag in your HTML, and then there's these little placeholders that I'll show you in a second that look like old school PHP. So we're all going to have to deal with that. But this is what it looks like. So imagine that we're streaming a page down to the browser. You can put a placeholder in. This could be like a full skeleton UI if you want. Again, no JavaScript necessary. Just put in whatever you want. Some time passes, your queries run, or gather all the data for the dashboard, and then we can render that just streaming down the HTML, and it will automatically replace that area. It's as simple as that in terms of an API. Annoyingly, I couldn't demo this with Rails because there's no way to manually flush between things yet. So if we were to actually integrate this into Rails fully, we'd have to do a little bit of work there just to tie that up. But we can also do things like we can append messages. So you don't have to use the kind of start and end marker. If you've just got like a placeholder that's not going to contain anything, you can just use marker as a shorthand. Anytime you inject this template into the DOM, it will effectively append it, and then we can put another marker with the same name back in after it, so that way we can continually append to it. Similarly, we can remove DOM nodes. Again, start and end wrapped around an element, and then we just send a blank template, just say, don't put anything in its place. And yeah, you can re-embed these identifiers, like I said, with the appending version. If you wanted just to replace something but allow it to be replaced again in future, just keep wrapping it in those tags. And this is all natively handled by the browser. So the moment this is a JavaScript-only API, but it's literally like a few lines of code to stream this in. So just say you made a fetch call, you're loading something, and you want to put it into the document, and you're not using the HTML streaming approach. Few lines of code, and I've even gone to the extent of wrapping it in the view transition thing here now, so that will automatically animate it as well. But where I think this could go, and this is just me speculating, and I've talked to the owner of the specification about this, is that we could have an implementation where our browsers could handle this API itself. So imagine you make a navigation like a link or a form, and it might be like an opt-in attribute or something like that. But we say, you know what? We just want one of those fragments back. We don't want a whole document. Don't send us a whole HTML response. We're just submitting this form and we want the changes. The server then could decide, yeah, okay, I can see that you're on that form from the referrer header. I'm going to just stream back that little fragment, just as Rails does, with things like Turbo. And then the browser just applies that to the DOM for us. That could be completely without JavaScript. And obviously, if the server decided, you know what, you're moving from one section to another, I don't want to do that as a soft navigation. I want you to actually go to that page. It just sends the whole document back as normal. So and the browser could handle that kind of regular flow. Or if it returns a redirect, it could just do the redirect just as it does today. So this tiny little tweak of how browsers work could be really powerful. And thankfully, you can actually polyfill this behavior. I built a little demo, just like an email sign-up form. So hitting submit, I get a little error. That's just returned as a little fragment. If I put my email address incorrectly, this is all just server-side rendered. And then I've actually given it the option of disabling fragments. So again, it responds to like if it just gets a whole HTML page back. I can't do a hard navigation for that, but I can just replace the whole page kind of TurboLink style. So this is an example of like how many plugins and things like that do we have across the web where it's like we just want this tiny little bit of kind of interactivity. How many newsletter sign-up forms do we have, comment forms, that kind of stuff. That could all just be replaced with a tiny little native thing. And then as soon as someone lands on this page, we don't have to download any JavaScript. They can just hit submit. If that JavaScript hasn't loaded, they don't even have to have that hard navigation approach where you get taken off to some other website. They still get that beautiful little confirmation message. So bringing all these things together, I will wrap up because I'm sure that everyone wants to get to have some beer. But yeah, I built this into a full demonstration. Again, the only bit of JavaScript running on this completely is the little patch for those fragments. So you can see here, I'm like resorting the page using those links. I've got I don't know whether I show the hovers on this bit. I might have skipped that by accident if I remember rightly. Yeah, I did. But you can obviously, make changes in this modal window. We are so close to this entire UI being completely JavaScript free. So this is how close we are. 614 bytes of JavaScript that whole UI took. And that's just me patching in that little approach. So I'm going to be pushing for this to be adopted by browsers. So we'll see how far I get. It would be my first ever browser API. So yeah, you can't really use this today. You could patch it, just like I did, but none of your users are going to use it because you actually have to enable certain flags in Chrome just to even get this preview. The flags are on the slides if you want to have a go. But it's definitely something that you want to follow for the next 6 to 12 months because I think the Chrome team will start talking about it more and more. So just in summary, I'll wrap up really quickly. View transitions give us that kind of fluid app-like feel. Speculation rules give us those instant hard navigations. Compression dictionaries remove so much of that network overhead that we've got across all of our kind of text resources. Invokers let us just completely remove JavaScript altogether. And our declarative partial updates are a potential future for standardizing soft nav directly in the browser, which would be really exciting. So was Rails really right in terms of where the web, how we implement the kind of front end of the web? Sadly, being right doesn't necessarily mean we're going to get adopted. So this is the popularity of these things, across origins on the web, which is, it does make me very sad. I think so many people could benefit from Rails. But if any of you have ever kind of invested in the stock market, you may have heard this phrase where it's the market can remain irrational longer than you can stay solvent. So if you start shorting things, you might be thinking, oh, there's an AI bubble at the moment. I'm going to start shorting the AI companies. You'll probably go bankrupt first. But I don't think Rails is going to go bankrupt, to be clear. But to me, it's like, it does show that we were kind of right. And unfortunately, we don't just win by just purely being right. But ultimately, the zero interest rate era is over. The business is changing. We do need to look to get more out of our tech. That's the big push with AI, like getting more out of our productivity. And we need to expect better from our tech as well for our users. We can't just have our productivity without supporting them as well. So really, my message today is try and see client-side JavaScript as a liability rather than an asset. Use as little as possible to achieve what you need, and try and, I'm not saying like if you've got a single page app today, don't bin it off. You don't need to suddenly park everything and spend a year rebuilding everything. But just, there might be things within it where next time you're implementing a component, like, I can just use a web platform API for this. So yeah, I think you'll find with Rails and the web platform, generally for 99.99% of people, they'll have everything that you need. Thank you.
Are there any questions?
everyone just wants beer.
So if you had a like Rails application, let's say, I don't know, 5 years old Rails app,
Mhm.
but unfortunately with React, what would you be your advice to actually get from this state to the dreamy one that you were describing?
That's a very good question. Actually, a useful one because it lets me cover things that I didn't fit in the talk. It was already long enough. So yeah, I think the first thing is making sure you're measuring client side performance. So a lot of us, we've got charts in Datadog and New Relic and all the good stuff, but most of those are kind of focused on the kind of back end performance. You really need something that's focused on Core Web Vitals. And I'm not just doing a sales pitch for my Cloudflare product. It is just like if you have that data wherever you get it, that's tremendously valuable because just because you're getting a fast response out of a server doesn't mean that your users are actually experiencing a fast experience on the front end, and that gives you the kind of ammunition to actually drive some change. If you recognize that this is really slow, if you see that in the metrics, like if you see that you've happened to build one that's really quick, that's wonderful. I would like to see that. It usually takes, when you're adopting these big frameworks, like teams of people to do like active performance work on them to keep them to make them fast and keep them fast. But yeah, once you've got the data, you can't optimize anything that you're not measuring. So that's the first step. And as I say, that gives you the ammo to go, look, we're leaving money on the table here by making this slow experience for our users. It's going to be frustrating. You can have more churn, or if you've got like a public site, like an e-commerce site, something like that, people are just going to bounce away and not transact with you. So you can start to correlate your web performance in certain tools with actual commercial value at the end. Look at conversion rates and things like that. So that's where I'd start. And then, I'd take an iterative approach of just, you look at what your biggest problems are, try and get to the bottom of those, and then, try and slice those out. And if some things are really difficult, well, maybe look for the kind of medium where it's like, this will have a medium impact, but it's a medium amount of effort as well, rather than the really hard but valuable stuff necessarily. Once you get a few wins under your belt, businesses start to see the kind of progress you're making. It makes that conversation a lot easier. If you start with a few things that kind of move things forward, you can see it in the data. Then it's easier to get investment to keep going and do the harder things. So I'll just look for the little things that you can rip out and be like, oh, this bit's really slow. We're just going to focus just on that.
Cool. Thanks. That explains a lot. I was maybe hoping that you would say that there is some magic prompt with make no mistakes.
If I could do that, I'd be implementing that right this second.
All right. Any other questions?
So if you're currently using you're using Hotwire, maybe you're using prefetching, maybe not. You're using broadcast on your models, and you're using more specifically than turbomorphing like on your pages, so that as a model changes by some event, some process, some job, the page automatically updates. With like all the tips that you've been shown here, how much do you end up fighting Turbo? Like, do you end up essentially like not using Turbo for some of these optimizations?
Well, I mean, so with Turbo, it's generally all right from my experience. Like Rails aligns itself kind of so well with the web. We've had things for like doing proper HTTP caching for decades. You can see it in the data, the chart that I showed kind of early on, that Rails is generally ahead of everyone else. So like you need the data on where is the performance problem. Generally, Turbo itself is absolutely fine. I think the exciting thing, like I said, about things like the last API that is kind of most similar to that world is that brings it standardizes what Turbo's kind of doing for everyone. So, if you've got component libraries that are built for that, we'd be able to integrate them with Rails in future. So rather than it being like Rails kind of parked off in its own little world where it's like there's going to be very few kind of front end libraries that implement Turbo natively and things like that and integrate that, we can reach into the broader community in terms of the front end, which will be really nice. So hopefully, because we can kind of support that rather than being like, oh, we kind of fight it with APIs that are trying to mask away the web, we can embrace the web and yeah, so I'd say make sure that you're monitoring stuff and you understand what is the problem. But yeah, I don't often see too many problems with Turbo. Some of the kind of typing, if you've got fast like type ahead solutions, you need to be aware of how much data you're sending back for that and how quickly you're rendering that stuff. But yeah, generally dealing in HTML is the fastest way rather than dealing in like JSON and then passing that on a client.
Thank you.
All right, thank you. Short one?
Yeah.
Okay.
We're very lucky in Rails. We have Hotwire, but what do you think about XHTML? Like, are there other options like XHTML?
That doesn't ring a bell.
Yeah. Sorry.
HTMX.
Yeah.
Oh yeah. I'm a big fan of HTMX. Yeah, I mean, as a kind of utility library, it doesn't, it doesn't kind of do a lot kind of behind the scenes. It's a very lightweight. It's almost like jQuery back in the day. Just kind of more integrated into your HTML. So yeah, I think it's again, I think part of the goal of HTMX is to kind of make itself redundant over time because the browser should be implementing a lot of what it's providing. Just like jQuery did, it was like we want to move the APIs forward so that then we don't need jQuery anymore. So yeah, HTMX is a great little library to be using. Basically, it provides a lot of little utils, and you can just straight up get stuff in your HTML. And again, it works really well with Rails because there's APIs there for like loading HTML in and just injecting it into the page. So that's faster than parsing JSON on the client. So,
All right. Thank you very much, Ryan.
thank you.